Okay, in this lesson we're going to look at graphing the trig functions, and in fact just looking at tables of values initially for the trigonometric functions. So quick recap, again, if we take any angle, angles start from the top side of the positive x-axis and sweep, positive angles sweep anti-clockwise. So if I take some angle, there's an angle finishing in the third quadrant, and I take some point there on the terminal side of that angle, x comma y, and that point is a distance of r units from the origin. Well, we now redefine our sine, cosine and tan functions, primarily because an angle this size, which is between 180 and 270 degrees, will not fit into a right triangle, so we can't use words like opposite, adjacent, hypotenuse. So we would define the sine, if this angle is theta, we'd define sine of theta as y over r, cosine theta as x over r, and tan of theta as y over x. Okay, and those definitions are important. You need to know them by heart, and that'll work for all angles in the coordinate plane, even acute angles, all of them. Okay, remember, if you sweep the angle and it finishes in quadrant 1, all of the trigonometric ratios will be positive in that quadrant. Sine will be positive because y over r will be positive. X and y are both positive in this quadrant, remember, and r is always positive. So y over r will be positive. So all of them. If I sweep into the second quadrant, well, any point in here, the x coordinate is going to be negative, the y coordinate is going to be positive. And based on my definitions for sine, cosine and tan, y over r would be positive, x over r would be negative, y over x would be negative, so only sine is positive in there. If I sweep an angle into the third quadrant, and in the third quadrant I remember that both x and y are negative, so y over r sine will be negative, x over r cosine will be negative, but y over x, the y coordinate divided by the x coordinate, will be a negative divided by a negative. So y over x will be positive, so tan will be positive in there. Sweeping an angle into quadrant 4, every point in here has a positive x and a negative y. So y over r, yes, that's right. So y over r will be negative. X over r will be positive, y over x, negative over positive, is going to be negative. So only cosine is negative in there. So one thing to remember, is this kind of idea. This tells me that in the first quadrant, all trig functions are positive. In the second quadrant, for any angle between 90 and 180 degrees, only sine of that angle will be positive. In the next quadrant, third quadrant, any angle between 180 and 270 degrees, only tan will be positive, and for any angle between 270 and 360 in the fourth quadrant, only cosine will be positive. Of course, their reciprocals, I should say, will also be positive. So in quadrant 1, all positive. In quadrant 2, sine and its reciprocal cosecant will be positive. In quadrant 3, tan and its reciprocal cotangent will be positive. In quadrant 4, cosine and its reciprocal secant will be positive. Okay. Okay. One thing to remember, the sine of every angle is either going to be positive or negative. And the sine of every angle, if I just draw an angle in here, for example, the sine of that angle will be positive because it's in quadrant, the sine of that angle will be negative because it's in quadrant 3, and it will be actually equal to the sine of its reference angle. And every angle you can draw, the sine of that angle will be either equal to the sine of its reference angle or opposite to the sine of its reference angle. And that's the same for all 6 trig functions. The cosine of every angle would be either equal to the cosine of its reference angle or opposite to the cosine of its reference angle. The tan of every angle is either equal to the tan of its reference angle or opposite to the tan of its reference angle, all the same. And you can figure out whether it's equal to the sine of the reference angle based on the quadrant it is. Remember, sine is only positive in quadrants 1 and 2, cosine is only positive in quadrants 1 and 4, tan is only positive in quadrants 1 and 3. Okay? So with that in mind, I'm going to start to construct a table of values for the trigonometric functions. I'm just going to look at sine, cosine, and tan, but again, you should be thinking about their reciprocals, cosecant, secant, and cotangent. And I'm going to do this without a calculator. I'm going to focus on special angles, and you need to be able to do this. I'm going to do it for degrees all the way up to 360. So starting with 0 degrees, looking at special angles, I hope at this stage you know the special angles are 0, 30, and 45, and all their multiples. So 0, 30, 45, 60, 90, 120, 135, 150, and 180 for the moment. And actually going on, also 210, 225, 240, 270, 300, 315, 330, 360, and if I kept going on, I'd have 390 as well, you know, and you could continue that. That could continue forever and ever, this table of values. Things we have to be able to do, we have to be able to convert degrees to radians. Well, 0 degrees is 0 radians. Remember, you know, from before we said that pi radians is equal to 180 degrees. Well, 30 is 180 divided by 6, so that's pi over 6. 45, 180 divided by 4, pi over 4. 60 is 180 divided by 3, so pi radians divided by 3. 90 is 180 degrees divided by 2, so this will be pi radians divided by 2, etc., etc. 120 is 2 60s, so that's 2 pi's over 3. Remember, 60 is 1 pi over 3, so 120 is 2 of those. 135, well, that's 3 45s. That's 3 pi over 4. 150, well, that's 5 30s, so that's 5 pi over 6. And 180 is, of course, pi. Okay? And you should be able to continue that. I'm going to continue this in a bit. And one thing I would suggest at some stage is just pausing the video and see if you can finish off the rest yourself. But I'm going to go through this stuff. 0 degrees is on an axis. It's not actually in any quadrant. The same for 90, same for 180. They are on an axis. They're not in quadrants. 30 degrees, well, that's in quadrant 1. 45 degrees, quadrant 1. 60 degrees, quadrant 1. You know, remember, if I sweep an angle of 30 degrees, it looks something like that. That angle, the terminal side of that angle, is in this first quadrant here, so that's in quadrant 1. 120, well, now we've moved into quadrant 2. Generally give Roman numerals for some reason. You know, I'm just going to do that. If you want to write in the number 2, that's fine. I'm looking at the reference angle. What is the reference angle? Well, if I look at an angle here, say in quadrant 2, like that, the reference angle, the reference angle is this angle in here to the nearest x-axis. That's the reference angle. Okay, so if it's in quadrant 2, we're talking about 180 minus the angle. But you should be able to, at this stage, with the work we've done, figure out the reference angle. Okay, 0's not in any quadrant. We don't think about a reference angle for 0. 30 degrees is its own reference angle. 45 degrees is its own reference angle. 60 degrees is its own reference angle. 90 degrees on an axis. We don't really think of it as having a reference angle. If I take 120 degrees, and again, just a rough picture over here, 120 degrees through 90, another 30. What's the reference angle there? Well, the reference angle is this angle in here. 120 degrees to here, it would take me another 60 to get to there. So what we get is 60 degrees here as the reference angle. And these are all degrees. And what you'll see is a kind of symmetry emerging here. 30, 45, 60. The reference angle for 130 is 45, sorry, for 135 is 45 degrees. The reference angle for 150 is 30 degrees. 180 is on an axis. It doesn't have a reference angle as such. We're going to look to find the sine, cosine, and tan of these angles. So we're looking for the sine of 0. And I'm going to look at a very quick way and run through this very quickly. And let me get started. At some stage I would suggest you pause the video, see if you can finish off the table, and then I will go through the whole lot and you can check with the video that it's right. Quick way to kind of remember this, sine, I'm going to start by putting things over 2 up to 90 degrees. I'm going to think of square roots all the time. And this is kind of a cheat, I suppose. What do they call it? A hack. Quick way of filling in this table. I'm just going to put in the numbers 0, 1, 2, 3, and 4 in there. So, root 0 over 2 is 0. Root 1 over 2 is a half. Root 2 over 2 cannot be simplified, so that's just root 2 over 2. Root 3 over 2 is as simple as I can make it. Root 3 over 2. Root 4 over 2, well, that's 2 over 2, which is just 1. Okay. One important thing to remember before I fill in cosine, well, cosine of any angle is always equal to the sine of 90 minus the angle. So if two angles add up to 90 degrees, the cosine of one is equal to the sine of the other. Again, that's stuff we looked at in class before, but I can start filling in the cosine now, because the cosine of 0 is going to be the same as the sine of 90. The cosine of 30 is going to be the same as the sine of 60. The cosine of 45 will be the same as sine of 45. Cosine of 60 is going to be the same as the sine of 30, and the cosine of 90 will be the same as sine of 0 degrees. Okay. Another thing to remember, and again another thing we looked at before in class, this identity is in your log tables, page 13. The tan of any angle is always the sine of that angle divided by the cosine of that angle. So I have the sine, I have the cosine. If I divide the sine by the cosine, I get the tan. 0 divided by 1 is 0. A half divided by root 3 over 2, well, that'll be 1 over root 3, or root 3 over 3. Root 2 over 2 divided by root 2 over 2, any number divided by itself is 1. Root 3 over 2 divided by a half, well, that's going to be root 3. 1 divided by 0 is undefined. The tan of 90 is undefined. If you type it into your calculator will tell you you're wrong. Okay, so there's the first quadrant filled in from special angles from 0 to 90 degrees. And again, one thing to think about is maybe pausing the video and seeing if you can work out the rest of these things. Remember the sine of any angle. Let me just flip back here. The sine of any angle is always either equal to the sine of its reference or opposite to the sine of its reference. Whether it's equal or opposite depends on the quadrant. In the next three angles we're in quadrant 2. So 120, 135, 150 all have terminal sines in quadrant 2. And sine is positive in quadrant 2. Cosine is negative in quadrant 2. Tan is negative in quadrant 2. So I can start to fill in this stuff. Sine of 120 will be equal to the sine, positive the sine of its reference angle. Sine of 60 up here, the sine of 60 is root 3 over 2, so that's going to be positive root 3 over 2. Sine of 135 on quadrant 2, so it's positive, and it's going to be positive the sine of the reference angle 45. Back up here, sine of 45, you remember, was positive. It was root 2 over 2, so it's positive root 2 over 2. Sine of 150 will be the positive of the sine of its reference angle, 30 degrees. Sine of 30 degrees was a half, so what we have is positive 1/2. Sine of 180, well, sine of 180 doesn't really have a reference angle, but I think about 180, which is over here. I think about a point on the terminal side there. You know, it doesn't really matter. I can pick any point. Pick the point negative 1 comma 0, which is 1 unit away from the origin. The sine is defined as the y coordinate divided by or the distance from the origin, which would be 0 divided by 1, which is 0. So sine of 180 is 0. Okay, cosine of 120. I want to look at cosine of 120. Well, we're in quadrant 2, where cosine is negative. The reference angle is 60. So cosine of 120 will be equal to the negative of cosine of 60. There's 60 degrees. Cosine of 60 degrees is 1/2, so that's going to be negative 1/2. And what I want you to do is really see the kind of symmetry here. If I look at the sine, the column at 0, 1/2, root 2 over 2, root 3 over 2, 1, root 3 over 2, root 2 over 2, 1/2, 0. And those numbers kind of repeat themselves. What happens is the signs change. So, going down here, cosine of 135 is going to be the negative of cosine of 45. Why the negative? Because we're in quadrant 2. So 135 is in quadrant 2. Cosine will be negative. It's going to be negative of cosine of the reference angle, 45. Cosine of 45 was root 2 over 2. So this is negative root 2 over 2. And you can see these same numbers keep appearing. Following the pattern here, the next thing would be root 3 over 2. And again, look at cosine of 180. Cosine defined as x over or. There's a point on the terminal side of the 180. The x coordinate is negative 1. Or is 1 unit. Or is the absolute value 1 unit from the origin. So cosine of 180, negative 1 over 1. That's negative 1. Tan is just sine divided by cosine. But again, you'll see the symmetry here. Positive root 3 over 2 divided by negative 1/2. That's going to be negative root 3. Notice the symmetry with this. Just kind of a bit of a reflection happening here. We're going to get negative 1/2 divided by negative root 3 over 2 is negative root 3 over 3. 0 divided by negative 1 is 0. Okay, so this is my table of values for the trig functions. At the moment we've done from 0 to 180. I would really recommend, if you haven't already, at this stage to pause the video and see if you can fill in the rest of this yourself. Okay, I'm going to continue with this and fill it in so you can check your answer at the end. 210, well 210 now we're into quadrant 3. 225 quadrant 3. 240 quadrant 3. 270 is, you know, on the y-axis, 270 degrees. Then 300 degrees, we're into quadrant 4. 315 quadrant 4. 330 quadrant 4. 360 is on an axis. 390, we're back into quadrant 1. You know, what does an angle of 390 look like? Well, an angle of 390 looks like this. Go from the top side of the positive x-axis around through 90. There's 180, there's 270, there's 360, and then 390 will be there. So we're into the first quadrant. There's the terminal side of that angle running up along there. Okay, looking at converting into radian mode, remember always that pi radians is equal to 180 degrees. So into radian mode, well 210, well that's 7/30s. Okay, which is 7 pi over 6s. Remember 30 is pi over 6. 225, well that's 5 45s. 45 was pi over 4. So 5 pi over 4. 240, well 240 is 4/60s, which is 4 pi over 3s. 270, well that's 3/90s, which is 3 pi over 2s. 300, 300 is 5/60s, which is 5 pi over 3. 315 is 7/45s, so that's 7, 45 is pi over 4, so 7 pi over 4s. 330, well that's 11 30s. So 1130 was pi over 6, because 180 divided by 6. 360, well that's 2 180s, so just 2 pi. And then 390, well that's 13 30s, so 13 pi over 6s. So that's what your table of values looks like so far. The reference angle, if in doubt, draw it out. 210 degrees, well that's around, there's 90, there's 180, so another 30 degrees will take me to 210. What's the reference angle? Well, the reference angle is that angle in there, around 180 plus 30. The reference angle here is 30 degrees. So we can fill in the reference angle here, 30 degrees. Same thing, reference angle for 225 will be 45. Reference angle for 240 is 60 degrees. 270 is on an axis, it doesn't have a reference angle. 300 degrees, again we have the symmetry here, we're just repeating these, kind of going the other way. 60, 45, 30. This doesn't have a reference angle. Reference here will be 30. Next one will be 45, then 60, then no reference angle, then 60, then 45, then 30, then no reference angle, etc., etc. Okay. We're into quadrant 3. I want to find sine of 210. Well, in quadrant 3, sine is negative. Sine of 210 will be equal to the sine of the reference angle 30. Oh, sorry, will be equal to the negative of the sine of reference angle 30. So that's going to be negative a half. Okay. And again, I'm just going to get these same numbers repeating. Negative root 2 over 2, negative root 3 over 2. Okay, 270, if I'm unsure about 270, if in doubt, draw it out. 270, well that's around there, that's that angle there. 270 degrees. Pick any point here. Let me pick the point 0, negative 1. That's 1 unit from the origin. Y over r, the y coordinate divided by the distance from the origin, or the modulus of the point, negative 1 divided by 1, is negative 1. Into quadrant 4, and we're going to have a kind of symmetry. In quadrant 4, sine is still negative. Okay, and we're going to have these numbers, root 3 over 2, root 2 over 2, a half. And then we're back here, 360 degrees. Well, 360 degrees is actually coterminal. Draw a little sketch up here. That's coterminal with 0 degrees. So the sine, cosine, and tan of 360 will all be the same as the sine, cosine, and tan of 0. So sine of 360 will be the same as sine of 0, which was 0. Cosine of 360 will be the same as cosine of 0, which is 1. Tan of 360 is going to be sine divided by cosine. 390 back into the first quadrant. All of these things are positive. Okay, in here. So remember, when we're finding sine, cosine, and tan of an angle, we look at the quadrant and the reference angle. Cosine of 210. Cosine of 210 is in quadrant 3. Cosine is going to be negative. It's going to be equal to the negative of cosine 30, which is negative root 3 over 2. Cosine of 225. Quadrant 3, it's going to be equal to negative of cosine 45, so negative root 2 over 2. Cosine of 240. Quadrant 3, cosine is negative, so it's equal to negative cosine of 60, which is negative 1/2. Cosine of 270, again 270 cosine, here we have drawn it over here. Cosine is the x-coordinate divided by or, 0 divided by 1, 0. We're just getting these numbers repeating themselves. Let me just fix that. Negative 1/2. So into quadrant 4, where cosine is positive, and again we're just going to get the mirror image of these, 1/2, root 2 over 2, root 3 over 2. positive, positive. Okay, tan is sine divided by cosine. Negative divided by negative. Tan positive in here. Again, another way to find this is tan of 210 will be equal to the positive of tan of the reference angle, tan of 30. So what we're going to get is positive root 3 over 3. Or you can say sine divided by cosine, which would be positive 1 here. And sine divided by cosine here will be positive root 3. 1 divided by 0, undefined. And we have a kind of a mirror image. Of course, we're into quadrant 4 here now, so tan is negative in these in quadrant 4. So what we're going to get is negative root 3, negative 1. Notice the symmetry here, root 3, 1, 1, root 3 over 3, negative root 3 over 3. For 390, well, 390 is coterminal to 30. We're in quadrant 1, so all my functions for 390 are going to be the same as their values for 30 degrees. So a half, root 3 over 2, root 3 over 3. Okay, and that table can go on, you know, forever and ever and ever. So make sure you can draw that table out for special angles. Make sure you understand that the sine of any angle is either equal to the positive or the negative of the sine of its reference angle. Which will it be? Well, it'll depend on the quadrant. On all trig functions have positive ratios in the first quadrant, only sine in the second, only tan in the third, only cosine in the fourth. Okay, so sine should always be negative in quadrant 3. Quadrant 3, tan should be positive. Quadrant 3, cosine should be negative. So that's special angles from 0 to 360 degrees. And in our next lesson, we'll look at graphing some of these functions from these tables of values. So make sure you can fill that table out, practice it, research it online, look at your textbook, but you should be able to do that. And again, you should be able to do it pretty quickly. Okay.